So today we are looking at six inequalities in two triangles. Our essential question: if two sides of one triangle are congruent to two sides of another triangle, what can you say about the third sides of the triangle? So we're going to have triangles where we have two sides congruent, and we're going to look at what I know based on the third side or the angle in between them. So our first theorem, the hinge theorem: if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is larger than the third side of the second. So if you look at the picture on the side here, VW and RS are congruent, VX and RT are congruent. So I have my two sides. 88 is bigger than 35. That means that WX is bigger than ST. This should make fairly decent sense. As I open it up wider, the side I need to connect those is bigger. It's called the hinge theorem. A hinge is what you have that lets your door swing open and shut. Right? The wider I open the door, the bigger the gap that I can enter. That is, the size of the door and the size of the entrance don't change. That's what this theorem is saying. That as I open up the door bigger, the entrance gets bigger. The converse also works here, right? If two sides of one triangle are congruent to two sides of another triangle, just like we had before, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So 12 is bigger than 9. The angle opposite the 12 is C. And the angle opposite the 9 is F. So angle C is bigger than angle F. So in example 1, right, I have AD is congruent to BC, right, based on my markings there. I have a second side, even though they don't mention it, because I can mark DB by reflexive. And then I have sides of 34 and 33. 34 is bigger, so the angle opposite that, which is angle 1, is larger. So angle 1 is greater than angle 2. When we look at example 2, right, again, I have sides that are shared in some of these, but I can make a comparison. So AD and CD. Well, AD is opposite 36. 36 is bigger than 32, so AD is greater than CD. On B, I have 22 and 24. 24 is bigger, so UR is bigger than TR. And here on C, I have the two sides that are equal, and I have this third side that's the same as itself, which is our reflexive property. So angle 1 and angle 2 have to be equal. Those triangles are congruent. Flipping it over on example 3, it says determine which flight is further from the airport. Right? So it says your flight flies 100 miles due west and then turns 20 degrees to the north and flies 50 miles. Right? Your friend's flight flies 100 miles due north and then turns 30 degrees to the east, right, and flies 50 miles. So your flight, we're going to do in blue. Your friend's flight, we're going to do in green. You fly 100 miles west. Then you turn 20 degrees towards the north. Now this is what always messes people up. I'm going in this direction. I'm turning north, which is up. I'm going to turn 20 degrees. So my angle looks like this. This is my 20 right here. I go 50 miles here, so my total distance is this. The angle I care about is not the 20. The angle I care about is 180 minus the 20. So this angle here that I care about is 160. We see something similar in your friend's flight. Your friend goes 100 miles due north. They turn 30 degrees to the east, which will be right. But I'm turning towards the east. So my 30 is here. So I have 50 and 100. This is my line that connects them. Again, the angle I care about isn't the 30, it's the angle in here, which is 180 minus 30, so this is 150. So your flight traveled a further distance away than your friend's flight. So your flight went further from the airport. Example 4, use the Hinge theorem or its converse in properties of triangles to write and solve an inequality. So I'm looking at how these two things compare. Right? I have a 3 and a 3, I have a 110 and a 102. Right? The 110, actually the 102 is not what I care about. Right? I have 102 and 27 in this one. Be careful of that. The angle I actually care about here is this angle. So we can do the math and solve for that angle by adding 102, 27 and subtracting those, which will get me 51. But if this is 102, I know this angle has to be smaller than 110, so I don't even actually need to solve it. I know 3x plus 2 has to be bigger than x plus 3. So then I solve this. Again, there's no negative sign, so my thing's not going to move. So I'm just solving it just like an equality. I subtract 2 from both sides. I have 3x is greater than x plus 1. Subtract x. So I have 2x is greater than 1. Divide by 2. X is greater than a half. And that is my... So x, this problem works anytime x is bigger than 1/2. And then our last one, example 5, which is a possible measure for JKM. So JKM, I'm looking at the angle right in here. Right? I have an 8, a 6, and a 25. Right? So either I can determine a possibility, not the exact answer, but a possibility. It should be less, more, or equal. If it's less, it's 20. If it's equal, it's 25. If it's more, it's 30. Since 8 is bigger than 6, based on our Hinge theorem, 25 has to be bigger than what I'm doing, so A would be my answer. And that is how we use the Hinge theorem and compare inequalities within two different triangles.